So far we have 4 shortcuts for proving congruent triangles. We have side, 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 when we know that all 3 sides are congruent to all 3 sides. We have side, angle, side, when we have 2 pairs of congruent sides and a pair of congruent angles in between the 2 pairs of congruent sides. We also have angle, side, angle, when we have 2 pairs of equal angles and 1 set of equal sides, and the side is between the 2 pairs of equal angles. And we have angle, angle, side, when we know 2 pairs of congruent angles and a side not in between the 2 pairs. We've also talked about side, side, angle, where we have 2 sets of congruent sides and an angle not in between those 2 sides. As we can see in the diagram, AC is congruent to DE, BC is congruent to EF, and angle A and angle D are congruent. And notice that the angle is not in between the 2 sides, and that's why the letter A is not in between the 2 S's. And we can see in our diagram that these 2 triangles are not congruent, because what happens when you fix 2 sides of the triangle, I can still change this angle here at C, and if I swing angle C out, I could create angle F, and you see that the red sides are the same and the blue sides say the same lengths, but the angle sides at C and F are different, and therefore we don't have congruent triangles, and that's why we know that SSA does not work. However, there is a special case of SSA that happens when you have right triangles. And when you have right triangles, we have a shortcut for congruent triangles called HL. And HL stands for hypotenuse leg. So if we have a right triangle, and if we know that the hypotenuse of one triangle is congruent to the hypotenuse of the second triangle, and they also have a pair of congruent legs, we can say that the 2 triangles are in fact congruent. So again, right triangle where the hypotenuse are equal and the legs are equal, just one set of legs. Now, why does hypotenuse leg work? Well, it works because of the Pythagorean theorem. If we fix 2 sides of a triangle, the third side of the triangle is determined by the Pythagorean theorem if it's a right triangle, which is the only time hypotenuse leg works. So let's say that the hypotenuse of this triangle is 5, and we'll make this leg 4. Well, we know by the Pythagorean theorem, our missing side here, we'll call it x, we know that x squared plus 4 squared has to equal 5 squared. And if we solve that through, we'll find out that x is equal to 3, the missing side of the triangle. And remember that AC is congruent to FE. That means that FE would have to be 5. And CB is congruent to FD. That means FD would also have to be 4. And so by the Pythagorean theorem again, we know that DE would equal 3. So in fact, hypotenuse leg is actually a special case of side, angle, side, because if you know 2 sides of the triangle, then you can determine the third side, and so you can see that you really do have 2 sides, one right here and one right here, and the right angle in between them. So hypotenuse leg is really a special case of side, angle, side when you have a right triangle and you know the hypotenuse and the leg. Okay, let's see what a proof using HL would look like. You can see we have 2 triangles here, triangle ABC and triangle XYZ, and we can see by looking at them they're right triangles. We see the right angles marked, and if we look carefully we can see that the hypotenusi are equal to each other and they have a pair of equal legs. So if we wanted to write up a proof, well, we'd start by saying we've got triangle ABC as a right triangle and triangle ZYX is a right triangle. That's given to us. And that tells us that we have 2 right angles, because if we have a right triangle, we have to have a right angle inside the triangle, and that would be our definition of right triangle. Now we also know that AB is congruent to XY, that's given, and that is our hypotenuse. And we know that AC is congruent to ZY, that's given to us, and there's our leg. So we can conclude that the 2 triangles are congruent by hypotenuse leg. Now it's your turn. You give it a try. Here are 2 triangles, and I'd like you to use the hypotenuse leg shortcut to help you prove that angle A is congruent to angle Q. Good luck!